when you learn about something new, a new concept, a natural question is why bother with those concepts, right? Why do we bother with abstract classes? Last week someone asked that question, so I'm going to answer it again. If you don't have an abstract class, let's say you have a class animal, and you want all animals to move, be able to move, but you don't know how it moves, right? And you're not willing to make the move function abstract, pure virtual, then you have to give it a default behavior. Right? If you give it a default behavior, you have to hope that anyone who extends your class will do the right thing and implement the move function. But you open yourself to the possibility of someone who doesn't do that. They can extend your animal class and they don't override the default behavior of move, and you're done. Right? So rather than that, you make it pure virtual so that it is compulsory for anyone who extends your class to have to implement that function. Another question is why we bother with interfaces. Anything you can do with interface, you can do with normal class. For example, this is a sort of a university theme design. We have a university, yeah? And these are interfaces, but so the university can request tuition from someone who could be either a student or a tutor. It can request teaching from anyone who is a lecturer or a tutor, and it can request a person to speak in front of an audience if that person is a person. If you don't use interfaces, then this is what you need to do. You will have to write these functions instead. So you have a function to request tuition from students. You have another function that requests tuition from tutor. And you have two functions to request teaching from two different classes. And you have three functions to request speaking from three different classes. So this is what you end up with if you don't use an interface, and then you just put all of these functions inside these classes. And so this is fine, it's okay. But what happens if in the future you realize that not only these three classes can give a speech in front of an audience, but a parrot can do that, or a robot can do that. Right? So if that is the case, then you will have to add another function here, request speaking from a parrot, or request speaking from a robot. Right? So you will have to constantly update your class, just to basically change the name of the class, of the input class. So it's not ideal. But if we organize it using interfaces, then we don't have to implement all of those functions. Instead, we will request tuition from anyone who can pay tuition. We can request teaching from anyone who can teach, and we can request a speech from anyone who can talk. And in the future, if you find yourself having to ask a robot to give a speech, then you can just make a class robot, which public talkable, right? And this is it. That's all you need. And then you can just instantiate a new robot and you plug it in with these functions, right? Like this. I can request Sophia to give a lecture in front of an audience, and it doesn't complain. So imagine that we didn't do that and we implement these functions instead. Then we have a problem here, right? So we use interface so that we don't have to write so many functions, and also it is future-proof if we want to extend our class space purely based on the behaviors of the classes. Now, sometimes it is legitimate that you don't need an interface. For example, if you implement a class flower and it has a behavior of bloom, right? Blooming is by definition a behavior of flower. So it's kind of redundant to declare a bloomable interface, and then only the class flower can implement the bloomable, nothing else can. So in that case, it is legit that you probably don't need that interface. But in a lot of cases, you can't predict what happens in the future. Right? Now we think talk is something that is inherently human, but in the future, anything can talk. So does that explain your questions? Yeah. All right, so let's go into today's exception. Again, this is another concept that you might think is unnecessary, because currently you've done 2 assignments without exceptions, and you were fine. And up to now, when you do your assignments, you still foresee some unpredictable problem, and you can protect your program against that with some sort of if statement, right? Which is quite doable. However, I'll show you why it is not ideal. So let's have a look. This is a normal way, right? Without using exception, I have a let's say this program is a program to build pubs. Right? So I declare these classes. Pub needs to have a leaker license. It needs to have resource consent to build a pub. Right? Just keep it simple. We need 2 sort of other classes. And then to get a leaker license, we need to request it from the council. To get a resource consent, we need to request it from the council as well. And lots of things can happen that results in our application being declined. Right? So if for some reason we get rejected, then the normal way is the function will return some sort of integer to signify that something is wrong. Right? So that's the reason why your main function usually returns 0 when it finishes without an error. So that's the source of why it returns 0. If the license is acquired successfully, then you can modify the license a bit, and then you, instead of return the license, you return 0 to signify that there's nothing wrong. And the license is passed by reference here. Right? So to request a license, first the caller needs to create an instance of the leaker license, and then pass it by reference to this function, to the request license function, and then get an error code back. And then if there is an error, then we know that this error occurs when we request a license. So we will return another error to the main function. This is not a main function, it's just a build pub function. So we'll return some sort of error to the main function. If there is no error, then this block will not be executed. Then we go ahead and we request resource consent, which I guess probably should be the other way around, but it doesn't matter. So now we have the license. We are requesting a resource consent, right? And again, when we request a resource consent, a lot of things can happen, and our application can get rejected. And in that case, we will return a negative number or any number to signify that it is not successful. If it is successful, then we will do something with the license here, which also is passed by reference, and then we return 0. Right? And the way we handle error, possible error, is the same. We create a consent, we pass it by reference to the request consent function, and then we check if the error is not 0. Right? If it is not 0, then we return a different error code to the main function. Remember, this function can return 2 different errors. So we need to declare 2 different types of error over here, so that the main function down here can understand what's wrong. Right? So the main function also will call build pub. Right? It still has to create a an instance of a pub and then pass it by reference to the build pub function. And then if everything is fine, the error here will be 0. If it is not fine, you will get either 1 for having your liquor license declined, or 2 for the resource consent declined, rejected, right? And then in 2 cases, you will print out the appropriate message, and then you return, non-zero. Otherwise, you do something, right? So this is the normal way that you see, especially in POC, in ANSI, when there is no class, there is no exception. This is what people do. When you open a file, what you get is not a file. What you get is an error, right? So this is kind of awkward. You would expect that when you call build pub and you get something in return, you should return your pub, right? So if I were an investor, I don't care about having to create a pub myself. I'm going to just give money to someone to build the pub for me, and what I get is a pub. I don't have to create a pub first and then ask someone to proceed. So this is kind of awkward. You have to pass stuff by reference or by pointer, and you have to do it a lot. Same here, you have to pass the license by reference instead of having this function return a license to you. So in terms of structure, it's awkward. In terms of semantic, it doesn't make sense. You get an error instead of something that you request. And in terms of the flow of your program, it's really difficult. You handle errors multiple times. You handle the error here, you handle the error here, and then you handle the error here. Right? Too many things to do. So this is the old way. But we can get away without using exception. Right. So up to now, we use if or assert statement to check for the error. And in many cases, because the return error is an int, is an error code, there is nothing stop you from not checking for error. Right? You can just go ahead and hope that it doesn't happen. You open a file, and normally you would check for file existence, but nothing stops you from not doing that. And if you don't do that, then you get some nasty error. So a more sensible way to handle errors is to handle errors inside of the function that sort of create that sort of error, and not in the main function. And also, you want your exception to be enforceable. So if your function returns an error, you want anyone who calls that function to handle the error, not just ignore it and hope that nothing bad happens. So this is without using exception, right? We have an array of 10 elements, and then we try to access what is this? Something that is way out of range, right? And then this violates the operating system's memory control, so it will terminate your program, and it will give you something like segmentation fault, or not this. You would just terminate your program without any notice, which is really bad. You don't want that. So to avoid that without using exception, you will need to check for the range yourself. So if someone enters something that is out of range, you have to handle that inside your main function. So the thing is, whether or not it is out of range should be the concern of the object that holds the range. So the object is an array. So the array should know that this is the range that I can operate in, not the main function. The main function shouldn't be concerned about that. And think about it, if you write your own array function, you can make the length of the array private, and the main function has no idea to know the range of your array, and it has no idea to do this. The reason why you can do this is because the language allows you to do this. But there is nothing stops you from creating your own array class without exposing the length of the array, right? So the idea here is anything that has to do with the object has to be done by the object. Error checking should be done by the object or by the function that that does the operation. Forget about this. Forget about this. Right. What goes here? So, as I said, without exception, you have to use the return value to hold the error, right? So if there is no error, you have to return 0. If there is an error, you return something that is not 0. But if for something that you must return by value, it's kind of difficult, right? So this operator will return you the value of the index of the element at that index. It cannot return two things at once. So if something goes wrong here, there is no way for it to return the error, right? Because this int is not an error code; it is the value. So when there's nothing wrong, then it can just return the value of the element. But if something goes wrong, then what happens? It cannot return an error code, can it? So you get yourself into this situation and you don't know what to do. Everyone understand this? Right. In case you don't, right? Previously, I used 1 and 2 as error codes to return for having the license decline. If I were to return something like -1 here, the main function can actually understand that -1 and -2, or 1 or 2, as not error, but actually the value that it tries to access. Right? So that's a problem. You cannot return two things at once. You have to choose. Obviously, one way to avoid the problem is to pass the value not by return but by reference. But again, it's extremely awkward. So, with exception, here. So in that situation, instead of returning anything, you don't return anything. You just throw an exception. So this is a new thing in C++. A function can return something, or it can sort of cause an exception, and which is not considered a return value. So we go from here to here. I want everyone to understand this completely. Why there is the problem here, and why and how is it solved in here. If you don't understand, ask right now. Understand? Yeah? In case you don't, right? C and CC only allows you to return one value. So you have to choose whether or not it is an error code or it is a value of an int value. C++ sort of allows you to return two things. Right? Whether you can return a value or you can return an exception. But if it is an exception, then the program will treat it not as a return value. So now you have a choice. You can either return something, or you can just ignore the return and you return the exception. So now let's go back to this application. Everyone agrees that this is a pretty awkward way to do stuff. You have to handle the errors so many times, and then you have to declare the errors. 1, 2, what happens if you have too many of these errors? And then the main function has to concern itself with so many things. It has to check for the error, and it has to know what kind of message is appropriate for the error. So this is not ideal. This is how we fix it, using exception, right? So everything is basically the same. We still have a linker license, right? We still have a resource consent and a public class. However, in here, when the application for the license is rejected, instead of returning -1 or returning whatever, which is not 0, to signify something wrong, we throw an exception with the actual message we want the user to understand, to know. And if everything is fine, then you just do the same thing that you did. Same with requesting a resource consent. So if anything is wrong, you throw an exception with the method that you deem appropriate. Now, so this is interesting. Now, this function doesn't do any checking at all. It will just go ahead and request a license, and then it requests a consent, and then it plugs in the license and the consent to the pub, and then return the pub. It doesn't really do any error checking at all, and you might think that, hey, maybe the programmer forgot to do it, or he tries to intentionally ignore error checking, but which is not what happened. What happened here is this function will just assume that everything is fine, but if there is something wrong, it knows that there will be an error returned, and the error, if not handled by this function, will be handled by the function that calls this function, which is the main function. Right? So everything is, you can assume that everything is fine until this point. If there's anything wrong, then this is where we deal with the problem. Right? So the main function will simply do one try-catch block. It will try to build a pub, right? And it knows that a pub might call other functions, and those functions might return an error or an exception. So it needs to catch the exception here. Now, instead of having to come up with the error message that is appropriate for the error, it simply calls something wrong. This something wrong is the exception object. It simply calls something wrong dot what. So this will basically return you this message or these messages. And these messages are deemed appropriate by the functions that create them, not by the main function. So your main function now is freed of a lot of concern. It doesn't have to do most of the error checking, and if there is any error, it knows it doesn't have to come up with an error message to print out the screen. So we come from how many lines? 85 to 66. Okay, doesn't look like a big difference, but remember, if you have one more class, if you have more than just 3 classes, then you save yourself a lot of time for not have to deal with errors in multiple places. And then it reads easier. First, we look at the build pub function. The main function doesn't create any new instance of the pub. It will just simply call build pub and expect the return value to be a pub. So it looks very clean. The return of build pub is a pub. Also, in the build pub function, the pub will request license for itself, not having to create instances and then pass those instances by reference. So the return value of request license is the license. The return value of request consent is the consent, which reads really easy, just like English. It's a lot easier to understand. So not just that you save yourself, lines of code. Your program reads a lot better. All right. So, is there anyone who doesn't see the benefit of using exception at this point? Just give me a hand up. I'll explain. No? Understood completely? Yeah? Okay. So let's move on. So again, in order to use the mechanism, the exception mechanism, we put everything that could cause an exception inside a try block. And then if anything wrong happens, it will be caught here in the catch block. Now when you get to Java, then you have another block for finally. It's not just Java, but almost every other object-oriented programming languages. have, but not C. So anything that can cause an error inside try catch. You can catch multiple types of error. So in here we catch only exception because it's the broadest class. But in practice, people tend to create new classes, new instances of the exception class. So instead of throwing an exception here, you can create a new class called liquor license exception. And then down here, you can create a new exception class called resource consent exception. And then down here, instead of catching one, you can catch liquor license exception or resource consent exception. So you can catch multiple things, not just one exception. And it makes sense to do that, especially when you have a complicated sort of structure of exceptions. Sometimes it is appropriate to print out the error here, but sometimes for some exception it is not appropriate to print out an error. You might want to do something before you print out an error. So you might want to deal with different classes of exception differently. But for this example, we don't need that complicated thing. So we threw an exception here and an exception here, and we can catch it here. Now, if we don't catch an exception, now we know for sure that these two functions can, in some cases, through an exception. If we don't catch it here by the build part function, then it would simply pass to the previous caller, which is in this case main function. Right? So if you have function A calls function B calls function C, and function C calls something that can cause an exception, and you don't catch any exception in that process, eventually the exception will be thrown back to the main function. And even if in the main function you don't catch the exception, then the framework will do that for you. It will terminate your program and it will print out the message. So it is impossible to ignore an exception. It will always be caught either by you or by the framework, by C++. And I'll show you that in a minute. Also, the last catch. So, well, I guess we have to explain something else. Now, in C++, you can throw not just exception, but you can throw anything. You can throw an int or float like this, like what we've seen before. Now, never, ever, ever, ever through something that is not an exception. Never, ever, 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 ever. Because an int is not a subclass of an exception. So if your program threw something, now in Java, because everything is in a subclass of exception, you just need to catch exception, and you know for sure that there is nothing that you don't catch. Right? But in C++, you catch an exception, but if your function returns through an int, you can't catch it. Right? So if this function, instead of throwing an exception, it throws -1, then your function here, even though it expects that something wrong might happen, it cannot catch that because it's not the same type. So you will have to, you are forced to write another catch for an int. And then if you predict that maybe some of those functions can return a float, and through a float, you have to catch a float. Or a string or anything. So it is basically impossible to catch everything. One very sort of shitty way to catch everything is this block. Catch ... So in here, if you don't catch an int, if you don't catch a float, if you don't catch a string, then it will go in here. The thing is, you lose the instance. It is an int because there is no argument inside the catch, right? There is argument inside this catch. If something wrong, you know that this is the instance of the argument of the exception, and you can ask what happened. But because there is no argument in here, all you can do is to say something is wrong, but I don't really know what wrong. So it's very shitty way, and no other language has this. So where are we? Here. Desire to catch any type of exception, except that you basically lose all useful information. So you understand what it does, but don't write code like this. Another thing is the order in which you catch exception is kind of important. So if you have this up from the board, now the mother of all exception is the STD exception class. You can create new classes like STD, not STD, sorry, like liquor license, liquor exception, and completely fine. But you have to remember the order of inheritance, and you need to catch the one that are more specific than the one that are less specific. So if I were to throw a liquor exception up there, it is totally fine to only have the catch exception, because we know that a liquor exception is an exception, so that it can be caught. Right? But if we decide to catch them separately, you must catch the liquor exception before you catch exception. And then you can print out x dot what here, and then you catch exception. If you swap the order, then when you have the liquor exception, which is right there, if you decide to do this, you catch the less specific exception class first, and then liquor exception. Then what happens is when you do have a liquor exception instance, it will go into this catch block, because the liquor exception is an exception, so this catch is valid, it will go here, and this is never reached. So must go before. Let me write down. Catch children catch children exception, and then catch parent, not the other way around. And the catch dot dot dot, it is considered the least specific. Right, so if you decide to catch dot dot dot, it must be the last one to write. Must be the last. Right. So it is quite possible that you get something like this in your exam. Right? A function returns some kind of exception, and then you have not one, not two, but several catch blocks, and they do different things. And then the question is, when you have this exception, what will happen? What catch block will be executed? And if you don't remember that you have to catch the more specific than the less specific, then you will have the wrong answer. And sometimes this is not appropriate to use exception, because exception is actually quite expensive in terms of computation. So if you have everything to check for, if the error checking is very simple, like checking for the range of array, and you know the size of the array, you should do that without calling something that can catch an exception. Especially when you have a while loop. So when you have a while loop, theoretically it can happen infinitely many times. So if you have a try catch here, and you do get exceptions, then you might get too many of them. So it can significantly slow down your program. So if you have a while loop and you have all the information to check for the error yourself, then do it. But if the error checking is too complicated or too convoluted, then a try catch is still better, even though it's a little bit slower. But in terms of reading your code, it's easier to understand, easier to debug. So I would say this is kind of bad. Right? You have a while function, and then instead of checking for the array size yourself, you just allow an exception to occur infinitely many times. So this is not ideal, but maybe some people might decide that it's easier to read, which is fine. All right, so with exception, the concern is separated. And in software design, separation of concern is a pretty big thing. Probably write somewhere else. Right. I think I have an example down here. I'll use my this example. So the error, the place where the error can occur when you request a license is inside this function. So it is this function's responsibility to create an appropriate message, and in case you have multiple languages, then it is responsible for this to find out what language your system is and then return the appropriate message for that language. It shouldn't be the responsibility of the main function. This is not where you request consent, basically. Now, in terms of programming, it doesn't matter where you handle the error or where you check for the error. But in terms of reading or in terms of structure, it's always better to separate the concern. So anything that concerns license should be dealt with inside a function that deals with license. Anything that deals with consent should be dealt with in a function that requests the consent, not the main function, not the build pub function. Again, C++ allows you to do anything. So an integer, a string, a float, a boolean. I think you can even do a null. So this is what happens when you do that. You have let's say we're building a house. Let me make it bigger. So a function that builds a house takes in an area, which is an int, budget, which is a double, and then the name of the city where you want to build a house. And then when something is wrong with the area, let's say it is too small, you throw the error. Something is wrong with the budget, you throw the budget. Something is wrong with the city, let's say it is too far, then you throw the city. So as a main function, I have to anticipate all of those cases and I have to catch them 3 times in order to print out the appropriate message. Now I can do away with using the dot 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 thing. Right? I can do this. But then in this case, I have no idea what goes wrong. It could be the error, it could be the budget, it could be the city. So it's very bad to do that. I cannot do this. I cannot catch an example.